Security requirements are non-functional requirements that strongly influence the architectural design of software systems. Security requirements and other requirements can conflict with one another. A common example is security and usability are often at odds with one another, and a balance between the two must be found. Therefore, you have to determine how secure do you want it versus how easy is it to use. Consider a wireless router. It's easier to not have to set a password to allow people to use it. However, that's not safe for your network at all. On the other hand, a 16-digit password with a daily changing PIN that has to be entered in order to access your network is much more secure. It's also highly unusable. Knowing about attack patterns such as phishing, SQL injection, cross-site scripting, etc. can make it easier to determine what and how to respond with secure methods because it gives you an idea of how an application and devices might come under attack. A security model is a formal description of software system security policy. It needs to capture 5 separate items. First, security policy objectives. Next, external interface requirements. Third, software quality requirements. Fourth, rules of operation. And fifth, specifications describing model system correspondence. With a good security model, you can work on securing your software. To be considered secure, software must exhibit 3 properties. Dependability. Will it operate under hostile conditions? Trustworthiness. The system will not behave in a malicious manner. And finally, survivability. That is, it continues to operate even when compromised. Therefore, security metrics and measures need to focus on assessing these properties. Threat modeling is a security analysis method that can be used to identify those threats with the highest potential to cause damage to software-based systems. Threat modeling should be done at the earliest phases of a project using the requirements and analysis models. Securing your system shouldn't be something that you plan early on in the project, because building a system and then trying to make it secure after the fact is both highly inefficient and prone to failure.